And hello guys. In this stream, my goal will be to make this terrain endless. We have this Minecraft world generation from last stream, and I just want to make it endless. To do that, we need multiple threads, all of this generated on the main thread. And how are we supposed to do that? Well, offline, I watched this cool video. This was the best video I could find on working with threads. And it's very simple. You make a thread, you start it and give it a function with work to do, and that's it. And in worst case scenario, we may need to use locks, so mutex locks. We'll see if we need to use them. We tried 2 times to do infinite terrain generation in Unity, and in Unity it was very difficult since we weren't working with threads, we were working with this iJobs interface. And so for this stream, let's see if we'll manage to do all the job in one stream, and we will see if in Godot working with multi-threading is much more easier and enjoyable. I'll be the judge for that. So we need to figure out where to go from here. Well, to see where to go from here, I would need to check the existing code because that's what we're going to change. And actually, I had an idea of something to do. The easiest thing we could try to do is just move all together all of the code in a separate thread. I want to see what will happen because look at now how when I press start, look how Godot lags until it actually starts. And yeah, here's all the terrain. And also let's actually just make the camera start from here. So what's the current position of the camera? Oh, I don't think I'll be able to do that. Actually, because this is like an override the in-game camera, and I don't suppose I can make changes to it. But let's see, do we see the position? I just want when I hit play to start from here. Position. Do we have a position somewhere? Yeah, this is the position. Can I copy it? Copy value. Copy value. Okay, I copied the position. Now, when I hit stop and when I hit start, yeah, I would just have to do it. Yeah, look at how only when I click here, that's when it creates it. And in here, I have to paste it. And it hasn't updated. Yeah, I don't know how to, or, this is important for us to do because uh, changing the camera starting position is important because currently look how we have to wait for it to load, and now it has generated everything. And when I move everything to separate threads, we'll be able to start normally without having to wait, and we'll see the generation in real time. And I just wanted, when we start here, it will make everything visible, like better to see. That's why I want to check if we can change the change Godot override camera initial position. That's the only thing I want. To see if we can change. This will be big game changer. Default camera.
Now, if I come in here, I can be able to do something more amazing. Now, one of the things I love about this is this particular feature that I have here, which is actually the idea of overriding our camera. Now, this is a very important.
Oh, Maybe it depends on this thing, on the actual camera. Let's change the actual camera position. And let's start it. Yeah. Okay, we solved it. And I want it to be rotated like that. Yeah, like this. So let's see its current rotation. Stop, and then for the camera, change the base value. And now when we start, yeah, this is it. We can even go a bit more far out, like this. And base value. And this is it. Okay, now everything is running on the main thread. I want to see if we can move all of it in a separate thread and to see what will happen. And then we'll figure out how to improve it even more. So subchunk manager has all of this code that creates the subchunks. So here, let's do thread. Let's do a thread. How does he do it? So he does thread new. Thread new. And then start. So thread new. And then here, let's move all of this. Function generate, create subchunks. And then I copy all of this code here. And then here, I'll do thread start, create subchunks, create subchunks, and now this already should be like multi-threaded. And he had some other thing to properly dispose the thread. Exit tree. He had this exit tree. And here I do thread, like to wait the thread, something like that. To wait it to complete, wait to finish. Wait to finish, and that's it. And look at how it immediately started. But there are some kind of errors. Call deferred, add child. Okay, it's complaining that the thread cannot do add child. Call, like it's saying call deferred, add child, and then node subchunk. More problems. Generate blocks. Get position on this node can only be accessed from either the main thread or a thread group. Again, it's saying to use call deferred. Can I do here like deferred call deferred. Hmm. So this is a scene, a new scene, and this scene has a function to generate like the blocks. And here, like what's call deferred? Calls the method on the object during idle time, always returns not. Idle time happens mainly at the end of process and physics frames. First call will be run until there are none left. You can defer calls from other deferred calls. Oh, I see. So let's go back. So it's like here call deferred and here the method. And now invalid access of index. What's the issue here? Get block. Origin is 0, 0. Index is 0. Blocks has all the needed values. And where is this? What's the call stack? What's the call stack? Where is the call stack? Stack frames. Update mesh. Okay, update mesh. Let's do update mesh to be called deferred. The same thing like here. Call deferred. Update mesh. And then subchunks. And we remove this. And it worked. It worked. So we managed in like few minutes to move all of the code in a separate thread. Look the difference. When I hit run, okay, absolutely no difference. No, we still have that waiting time. We still have that waiting time, sadly. Okay, this was just an experiment, just to get acquainted with threads. Let's move on to actually the main part of all of this, to make the world endless. So how are we going to do this? Let's undo most of this code. Here pass, and here just create subchunks, and here we remove the thread. Now we are like before. Yeah, just like before. So how are we going to make it endless is my question. Let me think about it. So endless. How are we going to make it endless? So we have all of these subchunks. We have all of these subchunks. Like here is one subchunk. This is one single subchunk. And we can move it around. Yeah, this is single subchunk. And it's filled up with blocks, and here these sides are not rendering since it's more optimized like that. So this little guy, currently they are not endless. currently they're not endless. How are we supposed to make it endless? So we can get the current player position and based on the current player position um, we can simplify it. Like every time there is a difficult problem, it's easiest to simplify it. So I could make it to generate only the chunk under us, and that's it. And we'll gradually expand that size to render more chunks around us. Let me think about it. So we need the current position of the camera. Okay, because we are using an override camera, does it change the camera position as well? That's what I want to see. Can you see remote camera? It's not changing the camera position. So how are we supposed to get the player position? So we will need an actual player, maybe. Godot get override camera position. Let's go inside the code and can I get like a reference to the override camera? No, I cannot. I think it's time to actually do a camera controller, but I can just attach an existing script. Yeah, we can use an existing script. And there's an issue as a parent of camera 3D. What's the issue? Extends camera 3D. Right. Get parent character body 3D. So it needs a parent. My camera. Oh, okay. The touch script. My camera. Yeah, now we have a camera and we can get its position. Also, let's increase the speed. And let's make it so when we press, let's add, when we press escape to quit the game. So project, input map, let's add an action quit, and let's make it be escape, close. And if input is action down, pressed, quit, then how to quit Godot? Godot quit shutdown game. get tree quit. Quit. So if we press escape, we should be able to quit. Yes, and let's make the speed faster. Move speed to be like 50. Maybe even more. 100. And we need, let's make it if to bring back our mouse so we can use the mouse. Toggle mouse. This should be the tab. Close. If in, let's just copy it. Toggle mouse. And here var show mouse false. And then where do I hide the mouse? No, I don't need a variable. Yeah, input set mouse mode. So input mouse. Okay, let's do the variable var show mouse false. And then function toggle mouse. If show mouse else. So if we are showing the mouse, I want to hide it. Else mouse mode visible, and then we toggle it. So here I just toggle mouse like this. So if I press tab, it toggles the mouse, and this looking around, where is it? Input look angles, set rotation. If not showing mouse, to set the rotation. Yeah, now we can actually use the mouse. And let's go back here. And let's look at how it's hiding away the terrain. This should be this part, I think, far plane. Yeah, we increase the far plane. Yes, and we'll set the position to be where we are now. Here, the current position. Copy value. We'll paste it here. And then the current rotation, we'll paste it here. And now if we play again, okay, perfect. And now we want to make some changes. We want some changes. So we want endless terrain and endless terrain. Let's get the player position or the camera position in the subchunk manager. So let's get access to it. Camera. We could call it the player. Player. Nice. This is for creating the subchunk. So here on when this subchunk manager node is created, we generate all the subchunks. Okay. What I want right now is to, instead of all of this, to maybe in the process function, to which is called every frame, to check for the player position and calculate what the current chunk we are in, and to generate that chunk. Only that chunk. Let me think about it. But at all times, we will need its neighboring chunks as well. So we will need and I'll make it easier. The plane will be one-dimensional. The plane will be one-dimensional. Here, I'll make it one-dimensional, where here is one subchunk. This is one-dimensional, like two-dimensional actually. It doesn't go. Here is just one subchunk. One chunk has multiple subchunks up and down. And we'll make it easier where here we just have one single subchunk. It should make it easier. And so as of now, I make it so here we spawn and only this subchunk will be rendered, but we'll need also the neighboring subchunks around it. So we'll need at all times 1, 2, 3, 4, 5. Access to 5 subchunks. Or like, is it 5? Like I'm focusing on making it as simple as possible. Let's bring back, let's highlight one subchunk, this one. So how many, so I want when the game starts here to render only this subchunk. That's render the player, that's it, very simple. And for this subchunk to render, it needs to know the blocks of its neighboring subchunks. So we'll at minimum need to generate this one, this one, this one, and this one without rendering them. Because if we have to render them, they'll need their neighbors as well. But I'm wondering if we should also generate this subchunk here. And this subchunk here, the diagonal ones. Because if the player goes like here, this one is all already generated. We just need to render it and to generate its neighbors. But if the player goes here directly diagonally, yeah, okay, let's generate all the neighboring subchunks. So it will be like 1. How many subchunks we will need at all times as a limit? 1, 2, 3, 4, 5, 6, 7, 8. So 8 subchunks, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 actually. Yeah, 9 subchunks. So at all times, I actually have a dictionary of all the subchunks. So let me think about it. Let me think about it. Okay, on start, this is create subchunks. So let's bring back this code here and let's actually just generate one subchunk. So let's generate one subchunk. Or like let's like instead of doing the for loop for now, for simplicity, let's get first the player position. Player position equals player position. Let's get the player position. And so we need to calculate the player chunk. Okay, so let's look at Minecraft chunk. And I think here it told how to get the chunk we're in. Like I think you have to divide by 16 to get the current chunk we are in. Yeah, here. Finding chunk edges. X and Z coordinates that are divisible by 16 represent the boundaries between chunks. Is a corner where 4 chunks meet. One of those chunks is between X 80 and 96 and Z coordinates. Another one is between when either X or Z crosses a multiple of 16, the player is moving across chunks. Essentially, the player is in the top left corner northwest of a chunk when both X and Z coordinates are divisible by 16. Additionally, the player can know the chunk they are on by this formula. Where the floor is the largest previous integer. Also, the coordinates of a block within a chunk can be found by taking the coordinate mod 16. So how much time? Yeah, we're 30 minutes in. For example, if the x coordinate of a player is 27 and z is minus 15, that player is on chunk and at within the chunk. So if player is 27 minus 15, okay, 27 minus 15, yeah. So So we var player chunk position equals player position divided by 16. And can we floor this? We floor it and then we multiply it by 16 to get the chunk position. And then, sorry, and then we have the player chunk position. We need all of its neighbors. We need all of its neighbors. So let's make a function. Generate like create chunk and then chunk position. And here we'll do only this part. Let's uncomment it. So subchunk instantiate, and then we set its position, and then we generate blocks, and then chunk position. That's it. And so here we need to create all the chunks. So create chunk, player chunk position, and all of its neighbors. And all of its neighbors, another for loop. So for x in, it's like 3 by 3 for, and let's do them like I and j. I in 3, like this. And here will be chunk. We need var chunk position, or like here var starting chunk position to be player chunk position, but minus 16 on x and z, and then var chunk position to be equal starting chunk position plus vector 3 I0j times 16 times 16, and we create the chunk. That's it. We create the chunk, and then we need to go through all the existing chunks and update their mesh. So can we do subchunks for each? Godot dictionary for each. For key in dictionary keys. Okay. For key, what's the key for position? No. Okay, let's do like for position in subchunks keys, and then subchunks position update mesh subchunks. That's it. Let's start it. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Exactly 9 subchunks. Perfect. And can we find it? Do we see anywhere? Let's override the camera. 3D. I'm not seeing anything. Let's look at the mesh instance. Mesh instance 3D. It should be able to tell me some information. Okay, let's look at the subchunk. Yeah, it has an array of zeros. Yeah, the blocks are zeros. Interesting. That's why nothing is generating. This one, zeros, 0. Everything is zeros. Okay, that makes sense. Here on ready, I go through all of them. Let's debug here. Chunk position. Why is the Y different? Okay, I need to change the Y. I need to change the Y. Yeah. Starting, so here Y to be equal 0. This way we'll be able to generate. Let's override the camera. Okay. Finally, okay, we'll make it by default to be rotated like this, downwards. So let's look at the override camera, copy the rotation, and update our starting rotation. It didn't update the starting rotation. Yeah, I want it to be like this. Player. Yeah, this copy value. Stop it in player. Paste. Start. Nah, it's the same. Never mind. Okay. We managed on startup to generate the chunks around the player. Technically, this is an improvement, but we want this to continue on. So when I move, to continuously track the player position. And so when we change position, wait a minute. Why are we... I shouldn't be rendering all of them. I just wanted one of them. Yeah, just one of them, because I wanted just one of them because here, look at how we generate these sites, and it renders faces on the border because it doesn't know the neighboring subchunks, what data they have. That's why we had this buffer of neighboring subchunks, so that when we move and we generate here more data, this to be like gone. So here we'll do starting chunk position. only that to update its mesh. Yeah. But why is it that one? Actually, why is it that? Oh, yes. It's the. It should be vector. Um, yeah. This will be the middle one. Vector 3. This will be the middle one. Yeah. Okay. Now it's actually rendering the chunk we are under. And I want, when the player moves, to hide this subchunk and to render this one that I am under right now. That's it. If we manage to do that, we'll be able to make it endless. And we're already like 40 minutes in. This will be harder than I expected. Let me think about it. How are we supposed to do that? Well, this process should happen here. So let's have a variable last player chunk position. And this will be like vector 0. And here we'll do like this. Like this. And here in the process, we'll be doing, we'll have to update our last chunk position. So it will be, so variable current player chunk position equals this. Why is it mat? Player position not declared. Yeah, okay. So it's like player position. So it's the player position, but I want the y-axis to be locked at 0. Now, if if the current chunk position is different than last player chunk position, we'll execute code. And what will be that code? What will be the code actually? How we have to, the previous subchunk that we had, we need to remove its like mesh. We needed to stop rendering and to render the current one we are under. Like, we need to do an update. Let me think about it. What I want is to have a object pool of subchunks to be able to free some of them but not be deleted, because deletion and creation is slow process. So when we have changed the chunk position, we have at all times 9 subchunks. We have at all times 9 subchunks. And we have 9 subchunks. And we've changed, we have at all times the 9 subchunks around us, as long as we haven't changed our chunk position. But here in the update, we found that the player has moved to a different subchunk, or like chunk. I'm ignoring the y-axis. And since we have moved to a different chunk, all the 9 subchunks, they need to change, at least some of them. We need to have the ability to free like subchunks and to get back subchunks that are, and to wait until some of them are freed. But how are we supposed to do that? Because currently subchunks are separate scenes. Yeah, they're separate scenes. Let me think about it. And I have a dictionary that has all the subchunks with the key being their position. So I could have another data structure that handles the ones we have freed. So here, when the first thing we need to do is free up some subchunks. That's it. We need to free up some subchunks. So once again, when we change subchunk, when we change our chunk position, we need to once again do this calculation. Where is it? Here, where this for loop, where we go and calculate the new 9 subchunks positions. And for each of those positions, we'll check if we currently have them like generated, because we go through all of them and we generate the blocks for those subchunk positions. But first thing we'll do is for all 9 of the new subchunk positions, we'll check in our dictionary if they already exist. Because if they already exist, we for sure have the blocks generated for them. So for all 9 of the new subchunks, some of them we will already have here, and the others will not be here. And for all the, like, let's say like we have like we generate like at all times 3 numbers, like let's say 1, 4, and 5. And next time we generate like 1, 4, and 16. 1 and 4 we already have, but this 16 we don't. And for each new one we don't have, we have a free spot. This 5 is now not needed. So all the subchunks that are not needed, we need to free them. And by freeing, I mean to put them in another data structure. Freed freed freeded freed subchunks. Do we have Q? Godot Q. Let's see now. Godot Q. Do we have a Q? Or like just a regular array? Yeah, just a regular array. Node 3D array. Like how do we Godot array? Just a regular array. Array. What happened? So it's like array node 3D, like this. empty. So we need to do the same logic. So here, the starting, like this. Now, current player chunk position, we have to subtract from the X and Z. And we go through and we calculate all the new subchunk positions. That's it. And for each one of them, let me think about it. Now we have to store them somewhere and to compare. We need to store them like let's do it like this. Var new chunk positions, new subchunk positions to be an array, and array of vector 3. We first just append them to the array, and then we need to go through the dictionary for subchunk position in subchunks keys. We need to go through the existing ones. And now, for each one, we need to check if it's in the new subchunk positions. If do we have contains Godot does element is element in array has if it has subchunk position. Actually, if it doesn't have, if our dictionary has a subchunk position that is not in the newly generated ones, we need to free it. So free it subchunks. We need to append it here. Subchunks and then subchunk position. And now subchunks, we need to remove it from subchunks. Do we remove it? Dictionary. Godot dictionary. Arrays. What does arrays do? Removes the dictionary entry by key. Do not erase entries while iterating over the dictionary. You can iterate over the keys array instead. Okay, they say to not erase while iterating over the dictionary, but we're iterating over keys, so it shouldn't be a problem. We erase this one. Now we have some free chunks, subchunks that we can reuse, and we have let me think about it. New subchunk positions. So we have to do else if like the newly generated subchunk positions is in the dictionary, we need to remove it. Erase. We need to erase it. Yes. Now, we need to loop through it. So for subchunk position in new subchunk positions. What's the issue? For block. Expected. Okay. Now, these are the new. Now we have an array of subchunk positions that are new and we don't have in the dictionary, but we have now free space for them, and we have available free subchunks we can reuse. Let me think about it. So we need to this create chunk code. We need another version of it. Let me think about it. We can. This is what we can do. We can. Yes. We can in subchunks. Subchunk position to be like we need var free subchunk. We need to get from free subchunks. Let's look at array functions. Godot. We need to pop out an element, any one of them. We don't care. We need to get an element. Pop back, pop front. We don't care. Removes returns the first element of the array. Appends and man. Pop returns. Removes and returns the last element of the array. Without jittering. Okay, pop back. This should be like probably faster. Pop back, I assume. Yeah, it removes it and gives it back. Sure. Free subchunk, and we link them together, and then we do create chunk with that position, and here we have to do a check if subchunk chunk position, or like get sub chunk position, it should be able to return null if the key exists. Like yeah, it returns null. So if like var existing subchunk, like freed subchunk, this is if it already exists, and if this is not null, else we execute all of this. So if we have an existing chunk we can use, we don't need to instantiate, we already have access. No, we can actually do it like this, sub chunk, and here like this, to be able to reuse code. And then so this is if it equals null. Subchunk. if it equals null, and then we do it like this, and then add child, we add child only if we are creating it for the first time. Generate blocks, and here we link it, and generate blocks. Generate blocks. Let's go back to the function to see if we need to make changes to it. It resizes. And yeah, sure, we need to regenerate. Sure. Resize, let's say it's not a problem. And then we and then we need to update mesh of the current player chunk position and current player chunk position, last player chunk position to be the current one. Finally, we can test. Now, if all of this worked, when we move, this should render the next subchunk. Okay, it did. It did. Yes. Yes. Oh my god. But it should be rendering only one at all times, and not generate the ones around it. So let me think about it. So when we free the mesh, here, when we don't need subchunk, let's create a function that clears the mesh. What's actually the issue? So I move to the right. It still renders this one, and it still renders this one. And now it still renders the one before, the new one, and this one has just updated the position, which just moved the previously rendered mesh. So we need to clear that mesh. Function clear mesh. And how do we clear mesh? Mesh instance 3D. Clear. How do we clear the mesh? Or like make it invisible? Maybe? To just not render. We don't need to even clear it. So in the chunk manager, this subchunk, let me think about it. This is a freed subchunk position, and so here in the create, else, we need this subchunk to make it like invisible. node 3D Godot mesh instance 3D Godot. How to make it in not visible? In visibility bool visible visible equals false. Okay, and subchunk here update mesh visible equals true. Okay, look at this, man. Here we're generating the chunk we're under. We're generating the chunk we're under. And this is all on the main thread. We're still not using multiple threads. But that will change. Let's GitHub desktop and let's save it. Generating subchunk below player. That's it. And now let's increase the render distance. The same thing as before, but not one subchunk, because right now like it's endless, but it's only one chunk below, and even that chunk is like only one level, like one subchunk. But right now I want, instead of only just having visible one chunk, to have visible like much more chunks to be visible. And it will be the same logic, but we need to do slight changes. So from the start, let's remove this old code. So from the start, we go and do work with 9 subchunks. Sure, we're working with 9 subchunks. We need to increase this, but how much? How much? So let's have some variables. Var render distance, and as of now it was 1. As of now it was 1, and this number 3 we got it by let me think about it. Render distance 1. What if we want to increase it to 2? Increasing it to 2. Okay, let's go. Let's render distance Minecraft. Or like again chunk. The chunk article. Render this. Render distance. Distance. Yeah, here we have some explanation of, because right now we have like render distance of 1. This, only 1. And it's endless. And I want to increase it, but I need the calculations of like what means, how many chunks is render distance 2, for example. Though chunk loading allow game features to occur relative to ticket type, chunk loading similar in the size, the side length of the square, it follows the formula. This is the formula. 2s plus this number minimum, where s is the selected simulation distance and L is the side length in chunks of the square. L. So let's so this formula, so 2 times 2 plus 1.63 is 5. And what's min? What's min? Can I do min? Minutes. What does min do? So is it like 5 the side length? Okay, so let's do like simulation distance, but this simulation distance of 1 and it does 3. So 3 by 3 is 9. Perfect. So what about 2? 2 is 5 by 5 side length. So 5 by 5 is 25. So if I want like to increase the render distance to 2, this will make it like 9. So like 1. So like let's open up some paint application. So here now this is render distance 1 and render distance 2 is this. This is the visible part, but we need the chunks around it. We need one more layer that is not visible but is generated. So render distance of 2 will have a let me think about it. So this was render distance of 1 had do I have a laser pointer? I think here there was laser pointer. Eraser. When it's render distance of 1, this was visible and all of this was invisible. And so side length, this is what I need, side length. It was 3 by 3. Render distance 2, all of this is visible and this should be invisible. So side length will be this and this. So it will be, I need more squares. So this will be visible, this will be invisible for render distance of 2. And side length increases. Before it was 3, now it's 1, 2, 3, 4, 5. Now it's 5. So this formula actually is working. Yeah, the formula is working. It's 5, sure. What about render distance? Like simulated distance of let me think about it. So 1, it was 3 by 3. 2 is 5. 3 is 7. Let's see 7. Let's see 7. 7 is like this, and then like this, and like this. So is it 7? 1, 2, 3, 4, 5, 6, 7. Yeah, it's 7. It's 7. Do I even need this? 7. So 1 is 3, 2 is 5, 3 is 7. Yeah, perfect. And 4 is 9. 4 is 9, so it will be like 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. Okay, so here we have render distance, and so side length will be 2 times render distance plus 1. And here will be, instead of 3, just side length. But here it should be, here I want to get the top left. That's why I remove 16 here and 16 here. So like this is from the middle to go toward the, I'm doing like, here is the player. From the middle, I went to here, diagonally. This is for render distance of 1. For render distance of 2, I need to go 2 times. So it should be times render distance. Times render distance. Yes. And then, yes, sure. And here, like this. And this should be able to, at least for the start, do it. No. Oh, because I'm rendering only like 1. Let me think about it. Now I need to go over the, right now, I just go over this one and I tell it to render. But I should have, oh, and render distance is 1. Let's do it 2. Yes. So now I should have generated, like all of these should be prepared for rendering, but I'm only telling this one to render. I need, and the starting point is here. I need it to be here. And to do a for loop going through them. So var offset to be render distance -1, and this to be by offset. And let me think about it. It should be like minus. No. How to get, because like I want, like this is the current chunk. I want, if render distance is 1, to just tell it to render. If render distance is 2, to tell all of these to render. If how to do that? So I need this starting one. Okay. Let's get the current player. Like let's make it a function. Function. Render visible subchunks, and here let's get the current player position, and if render distance is 1, I'll just update the one subchunk, only one subchunk. Here like this, and here like this, and now else I need to go back. How much do I need to go back? Render distance 1 is this, render distance 2 is this. So I need an offset, so this to be vector 3 16 0 16, so it's a minus, but times render distance -1. Yeah, and we don't even need to do the if else. Probably. Let me think about it. Okay, it should be like var starting subchunk from where we start, and then it's from the current player position minus this monstrosity, and this is for the else case here. Let's go back to the drawing. So if render distance is 1, it will just tell this one to render. But in all other cases, we need to go back and do a for loop. So we have this one or this one. We need to calculate the side length. Now currently, like this is for render distance 1, this is for 2. So side length will be var side length will be 2 times, I think, render distance -1, like the previous formula, just with render distance -1, I suppose. And we do here the same thing. like this, and then starting subchunk, and we do this. This should be it. Is it lagging? Now we have more terrain. Godot show FPS. Godot profiler. I need a profiler. The profiler should have an FPS. Where should I see a profiler? Where can I find a profiler? The debugger panel and clicking the profiler tab. Debugger, yes, here. Profiler. And does it have FPS? Stop. Yeah, let's just output the frame rate with a print. Inside of here, print like this, and we start it. So it's like saying 15 FPS. Why? And let's look at, let me think about it. Here, if there is a change here, this should be side length. This should be side length. And here it should be this thing, the starting one. And then this should be it. Now we have more terrain, but it seems to be lagging a lot. It's endless. It's definitely endless. Let's put render distance 12. And this is it, and it's lagging extremely much. And the problem is not because of the rendering of the subchunks, because we've managed to render all of these subchunks without issues with the lag. This lag is coming from somewhere else. But where? Um, render visible chunks. So this happens every frame. So let's go here and let's start it. Actually, I can simplify it because the lag happened even with small render distance. Yeah, okay. How to continue? Yeah, how to continue? Pause. Continue. 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 Okay, it's all the time has issues. Last player chunk position is always 0. Yeah, that's why it has lag. It's always going through this if. Okay, here in the ready, here we'll do we need to get the, so it's like player chunk position, player chunk position, and the y to be equal to 0. That's it. And here it should be equals current player position. Okay, now only when generating the terrain there is lag, but it's endless. It's actually endless. And now let's do bigger terrain, render distance 12. And we will have lag only when generating because everything is running on the main thread. Yeah, like right now. So if I move forward, like it's not letting me move forward because of all the lag. Yeah, now it's generating. Now it's generating. I'm trying to, yeah. So it's technically endless. It's technically endless, but it lags a lot since everything is on the main thread. Let's lower the render distance to something we can manage, 5. And for 5, it's also bad. Let's do 4. What's the minimum? Um, let's do 3. Well, it's endless. And I think it's best if we leave multi-threading for another stream. Because we are past 1 hour. But technically, it's endless. And this problem with the lag, we will solve with threads. And I studied threads just for this stream, thinking we'll use them now, but it's actually for the next stream, sadly. Come on, I really wanted to try out threads. Yeah, but technically it's endless. And actually, we're just, we don't have much height. This is so bad This is very bad performance because I'm not even generating the terrain below it. This is only just very shallow terrain, extremely shallow terrain. So I don't know if even threads will manage to handle all of this. We'll see. But I'm excited that we have endless terrain since my Java OpenGeo Minecraft clone that I've invested so many hours in doesn't have endless terrain. Yeah, okay, we'll optimize it and fix it in the next stream. So thanks for everyone for joining.